Hello friends, this video on alcohol, phenol and ether part 14 is brought to you by examfear.com. No more fear from exam. The next type of reaction is the reaction where my CO bond is broken. So here I have R, let's suppose CH2OH kind of thing. So here this bond is breaking. CO bond is broken. So we'll see different kinds of reaction. The first is with hydrogen halide, this is HX. So I have RO, which is my alcohol, reacts with HX, this bond breaks, you get RX plus H2O. This is a Lucas test, actually very famous test. This is used to differentiate between primary, secondary and tertiary alcohol. If the turbidity which you get is pretty fast, immediate, this is 3 degree alcohol. If it is after 2-3 minutes, it is 2 degree. And if there is no reaction, we say that it is 1 degree alcohol. We'll talk about the Lucas test. This is Lucas test for turbidity actually. Right? So there we use alcohol plus HCl. It gives ZnCl2. That's right. Alcohol plus HCl, it gives you, in the presence of ZnCl2 actually, you get turbidity. That is RCl. Now this time when you get this turbidity decides whether it is 1st degree, 2 degree or 3 degree. If it is immediate, it is 3 degree. It takes 2-3 minutes, 2 degree. It doesn't happen, it is 1 degree. Okay. Here carbocation is formed and it can be either SN1 or SN2 reaction. SN1 or SN2 depending on it is 2 degree or 1 degree or 3 degree. Right, so since it is SN1 SN2, it is carbocation formation is there, correct? So if you want, I can write the mechanism for this. So let's see, this is ROH and this is H plus X minus, right, HX. This is a pretty fast thing. My H plus will attack this oxygen lone pair, or better I'll write this oxygen lone pair will attack H, because this has electrons, right? It's reversible actually and fast also. So what you get is ROH2 plus X minus, right? This protonation is done because OH is not that great leaving group, but H2O plus is a good leaving group. So now I have ROH2 plus. So it is a slow process now. You get R plus and H2. Now you got R plus, it is a SN1 reaction. So R plus now will react with X minus. So it will give you RX. RX. Correct. So it is a nucleophilic substitution reaction. And if we talk about the hydrogen halide reactivity, we have discussed this so many times. HI is best, then HBr, then HCl, right, that way, and then HF, rarely used. And if you talk about the alcohol reactivity, 3 degree is fast, 2 degree and then 1 degree. And that's why this reaction is used for in Lucas test. They told this is Lucas test where we want to find whether the alcohol is 1st degree, 2 degree or 3 degree. Right? So if it is 3 degree, it is immediate turbidity. It is 2 degree, it is 2 to 5 minutes. You get turbidity. It is 3 degree, there is no reaction. Right? This is my Lucas test. And this says nothing but same thing. The CO bond is cleaved. So I have ROH, we react with HCl in the presence of ZnCl2, you get RCl, and this is turbidity. So let's see the alcohol reaction with PX3, that is phosphorus trihalide. So here what we do is we have this alcohol, we react with PX3, you get Rx and H3 PO3. So for bromoalkane, cycloalkane, I'll write for bromoalkane and chloroalkane, we react either with PCl3, PCl5, PBr3. For example, I have C2H5OH, I react with PCl5, I get C2H5 Cl plus POCl3 plus HCl. But for iodoalkane or I, we react with red phosphorus and iodine. For example, I have CH3OH plus iodine, we use red phosphorus, I get CH3I plus H3PO3. Why I don't use HI here? Because for example, I have CH3OH, if I use HI, this HI will reduce CH3OH to CH4. So that's why I don't use. I think we have discussed about these things in the haloalkane chapter. So I won't discuss much here. We have discussed this actually. So let's move ahead with thionyl chloride. So thionyl chloride is nothing but SOCl2. So here, for example, I have ROH. You react with SOCl2. The CO bond anyway will break here. You get RCl plus sulfur gas and HCl. And you have this in the mild basic condition. For example, pyridine, it can be as a catalyst. So alcohol reacts with thionyl chloride in the presence of mild base, maybe pyridine, to form haloalkanes. And this is a good method. Why it's a good method? Because SO2 is a gas, it emits, right? HCl is a gas, both are gas. It goes off the system, but please note they are poisonous. So care has to be taken, right? What you get is output is exactly RCl only. There is nothing else. So you don't have to do any filtration to get RCl, because these two are gases and they goes off the system on its own, but they're poisonous. So you have to take care of this, right? So we'll see the reaction mechanism on this. So let's see. CH3, CH2OH. Correct? Let's see this reaction mechanism. So I have SOCl2. So this is how I have this guy, SOCl2. Correct? So oxygen is slightly negative, it will get negative charge, slightly positive charge. Since the slightly positive charge oxygen has lone pair, it will give electron to this guy, right? So what it will form is CH3, CH2O. Since oxygen has given electrons, it will get a positive charge, S, and then I have Cl, and then I have O minus here, right? One more here, I had O minus. Correct? Now this O minus will kick this chlorine out. So this will go in this direction, go in this direction, kick the chlorine out. So what you get is CH3, CH2, O plus, still will be there, I think, yeah, it will be there. O plus, S, O, Cl. Yeah, this is what you get. The chlorine is out. Now, what will happen is, there is a positive charge on this. This SO2 will come out. There is a positive charge on this oxygen. Sorry, I missed H here. There was an H here. Right here also there is a H. Correct. Also there is a Cl minus in the system which we have got from here. Now this oxygen will have a positive charge, it will lone light. So hydrogen will come out, and we'll say oxygen will take care of the positive charge, right? H plus will come out. This is we have seen. So with this, what you get is CH3, CH2, and this SO2 gas will also come out, and this chlorine will join this guy, Cl plus SO2, and this H plus and Cl will combine to form HCl, and this is what you will get. See how it works is SO2 needs double bond here, right? So this chlorine will come on as Cl minus, will get a positive charge. This will come out as minus, get a negative charge, and that will form a bond. So you get this compound. Let's see the dehydration reaction now. I think we have seen this reaction so many times, dehydration reaction. So when you treat the alcohol with protic acid, like H2SO4 or H3PO4, and give some heat, the water molecule is lost. For example, I have this compound HNOH. Now here also if you see CO bond will break, and this you get H plus and some heat, you get alkene, and water comes out. This is the dehydration reaction. If you want to see the mechanism, I'll show you. H plus, oxygen has this lone pair, it attacks with H plus. So what happens here is the next is carbon has OH2, the positive charge with oxygen. Why? Because oxygen has given electrons, so right, oxygen gets a negative charge, positive charge. This is fast. Now OH2 has to leave, right? OH2 leaves, and this gets a positive charge. This is slow. Now since this carbon has got a positive charge, it has to stabilize. This hydrogen says, okay, I'll leave. So this hydrogen says, I'll leave. Right, so it gets a negative charge here, negative and positive will form a bond, and H plus comes out. Correct? This is the reaction mechanism. And also observe that tertiary alcohol, that is 3 degree alcohol, goes hydration easily. This is why? Because here carbocation is formed, right? So 3 degree will form carbocation easily. So for example, if you see, I have C2H5OH, you need H2SO4, and you need a high temperature of 445 Kelvin to make it to alkene. Same thing if you have increased the degree, this is 1 degree, right? You make it 2 degree here. You say CH3, CHOH, CH3 is 2 degree. So here you need only 85% of solution H3PO4, and also you need less temperature, maybe 440 Kelvin, and with this you'll get alkene. If you have tertiary alcohol, life is all the more simple for you. Example, you have something like this, right? Then you need only 20% H3PO4, you will need even less temperature, maybe 355 Kelvin, and you get something like this. Correct? So dehydration is easy for 3 degree alcohol. Now we'll talk about oxidation. So before we talk about oxidation, let's say some of the common oxidants we have in the market. So let me write it for you guys actually. So if we talk about the strong oxidants, we have HNO3 is one, chromic acid H2CrO4, chromate salt CrO4 2 minus, dichromate salt Cr2O7 2 minus, permanganate MnO4 minus, maybe anything, potassium permanganate. Then I have pyridine chlorochromate, actually PCC, and then I have pyridine dichromate PDC. Right? So there are so many oxidizing agents. These are all my strong and these are my weak. Correct? These are the common oxidants in the market which we use. So the typical oxidation reaction will be something like this. I'll show you. I have CH3, CH, OHH. We do oxidation of this. What you get is CH3COH. If I further do oxidation of this, I get CH3COH. Correct? This is the typical reaction. Here if you see, we are breaking CH and OH bond. These bonds we are breaking. So CH and OH bond we are breaking and we are forming CO. You see, that's what we are doing actually. Correct? It all depends on how strong oxidizing agent it is. Correct? And it is also called dehydrogenation reaction. For example, I show you this reaction now. Right? If you add an oxidizing agent here, so this bond breaks, and what you get is RCOR. So if you see, what we are doing is we are removing hydrogen, right? 2 hydrogen. So it is also called dehydrogenation reaction. But actually, this is the oxygen which we are providing, right? Actually, if you see the reaction is like this, H2O. These 2 hydrogens and this oxygen combines, right? 3 things combine to form water. But at the end of the day, from this reactant, I am removing 2 hydrogen. It's also called dehydrogenation reaction. Correct? This is also used to test actually whether it's primary, secondary or tertiary alcohol. Why? Because if I take 1 degree alcohol, right, if I do oxidation, it will give me aldehyde. If I do further oxidation, make carboxylic acid. I'll show you the reactions. If I take 2 degree alcohol, if I do oxidation, I got ketone. If you see here, I got ketone here, right? This is 2 degree alcohol. And here, if you see 1 degree alcohol, I got aldehydes. And then furthermore, I got this is 1 degree, it's 2 degree. Ketone. And further, if you oxidize, you're getting a carboxylic acid. Three degree alcohol, if you have, if you try to oxidize, there is no reaction. 3D or 3D tertiary alcohol, it doesn't undergo oxidation. Why? Because there is no beta carbon ion, the beta hydrogen. It has to remove the hydrogen, right? There is no hydrogen here. In fact, in this you can also add copper and Ag. This is also used as a strong oxidizing agent. So let's see some of the reactions here. For example, I have RCH2OH and then I add CrO3. It is actually a weak oxidizing agent. You get RCOH. But same RCH2OH, if I add KMnO4, right, in acidic medium or in H plus after that, I get RCOH. Right? In both cases, we are doing oxidation, but it depends on whether the oxidizing agent is weak or strong. So let's see more reactions. I have CH3, CH, double bond CH, CH2OH. I add PCC. It's a weak oxidizing agent. So what will happen is I'll get something like this. COH. Correct. Let's take one secondary alcohol oxidation. So I have CH3, CH3OH. I oxidize it. I get ketone here. Right? This will become ketone. And there will be H here actually. Yeah. And then I'll further oxidize it. What I'll get is CH3 COOH and HCOH. That's what we'll get. Okay, so please note tertiary alcohol, right, under normal condition they doesn't undergo oxidation. Why? Because it doesn't have the alpha hydrogen. Alpha hydrogen is not there, correct? Because if you see here, this is alpha hydrogen, it has to be there, right, to be removed. That is not there. Instead of H, I have some R group to remove to hydrogen, right? This will not be there. So under extreme condition only it goes. Oxidation will not study about that. Under a very, if you want, I can give you one reaction, very, very extreme condition. So this is CH3, CH3. This is my tertiary alcohol. This oxidation underscore nitric acid. Very extreme condition, you get something like this. And then further oxidation you can do further oxidation. This we have done actually. This is same as this. Correct. Also, heated copper is used for oxidation. For example, I have RCH2OH. So instead of CrO3, I could have used copper also. And 573 Kelvin because there is a heated copper. Correct. You can write one reaction if you want. RCH R dash OH, you have copper, heat, you get R COR dash. Correct. So we see that this is oxidation. So let's see this reaction based on oxidation number. So let's see this reaction and we'll see the oxidation number difference. Right? CH3, COH, H and H. When you oxidize this, this becomes CH3, COH. Correct? You further oxidize this, it becomes CH3, COH. Let's see, this is carbon 1, this is carbon 2. I'm just changing number just to find the oxidation number for carbon 1, let's suppose, right? So let's write it here. Carbon 1. CH3 will be 0. 0 plus OH minus 1 will be minus 1. 2 hydrogen will be plus 2. And this carbon, let's assume it's X, is equal to 0. If you find the value of X, X comes out to be minus 1. So here oxidation number is minus 1. Let's do for this guy, carbon 2. So this is CH3 0 plus this O is minus 2 actually, and this hydrogen is plus 1 plus X is equal to 0. You solve, you get XS plus 1. So you get XS plus 1 here. Solve for this guy. CH3 is 0, O is minus 2, OH is minus 1 plus X is equal to 0. You solve X, X comes out to be 3. So if you see the oxidation number changed from minus 1 to plus 1 to 3. And thus if you see that, this is the oxidation reaction. Correct? If you can do for any reaction, here also you can see do for any reaction, you'll see that the oxidation number is increasing from left to right. And that's why it's called oxidation reaction. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.